Okay, hi everyone, nice to meet you. I'm Saelyne. Today I'm going to present our work on video editing with natural language and sketching. So this work was led by Bekzat and was collaborated with Michal, Alex, Juho, and me. So informational videos are a popular source for sharing procedural and conceptual knowledge. So people learn how to achieve a task, such as making a pasta dish, from how-to videos, and students learn some new concepts and skills from educational videos, and experts share their opinions and comments through review videos. These informational videos are they require editing to ensure quality and engaging delivery. So this editing task contain organizing raw footage and selecting and sequencing some clips and cutting and trimming the clips and also adding media assets and effects. However, editing videos with existing commercial video editors are hard to learn or use, especially for novices. While they offer a great number of functionalities, it could be cumbersome to learn how to use them, and also they require this manual use of editors. So existing work tried to make video editing less tedious and more efficient, which you can generally categorize into two approaches. The first part is to automatically apply appropriate edits, such as placing cuts in interview videos and or applying edits in demonstration videos. The second approach is to generate edited videos from scratch. So it includes generating a marketing video from one web page and generating mobile tutorial videos from text or instructions. While these help users edit videos more efficiently, they provide limited control over the process, which inhibits the novice's ability to express edit requests. So on the other hand, natural language and other modalities have been found to be very effective for supporting intent expression, such as tasks like web styling or writing stories or image editing. So in this work, we investigate how multimodal interfaces can be used in editing informational videos. So we conducted a formative study with 10 video editors, and they were asked to express video editing requests for live stream footage. They were asked to express this request in Google Slides using natural language or images or shapes or adding other media assets. And we chose this 5 live stream footage because they are unedited long videos. And we covered this like diverse topics and knowledge characteristics and content format. And as a result, we collected 176 edit requests. And some of the examples are like whenever the camera is facing down to the pen, crop it so the pen is centered. And another was about every time any like surface goal is mentioned, show it on the screen. So from the analysis of the collected edit requests, we have come up with these design goals. First, enable expression of edit comments with natural language and sketching on the video. And second, based on the edit comment, the system should support interpretation of temporal locations in the video, spatial locations within the frame, and edit operations with appropriate parameters. And lastly, we should support iteration on edit comments and manual editing of interpretation results. So this is how the overall interface looks like. So on the left, we can see the video, and then on the bottom, there's a timeline where you can navigate through the video. And on the right, this is an interface where users can request an edit, and the bottom part of the interface shows the suggested edits. So ExpressEdit supports this 7 types of edit operations: putting a text, putting an image, shape, and cut the video, and crop the clip, and zoom, and blurring. So in the beginning, users can create a new tab, which creates a new layer on top of the video that contain edits. And then the user types in whenever a tip or device is mentioned, put a text with a transparent background and specifies the spatial location. And once the user enters in the edit request, then the system parses the edit command, and it breaks down into the into temporal references to the video, spatial references, and edit operations. So once the user confirms it, the system suggests the several edit suggestions. So it shows the temporal, like the timestamp of the video where the edit should apply. And also it shows the preview of the edits. And it also provides this explanation on why the system considered this as an appropriate edits. And it also provides this summary of edits at the end, so the users can toggle on and off each of the edits. And lastly, users can manually adjust the like position of the edits through this manual editing interface. So this is the pipeline part. So our pipeline is supported by the computer vision and large language models. So we first interpret the temporal location from the natural language. So here, whenever a display appears. And second, we interpret this spatial location from the natural language text. And then finally, we identify this edit operation. And our pipeline consists of two parts, offline and online parts. And for the offline, we first process this textual information from the video. So we run blip2 to capture this captions and objects appearing in the video. And for the actions, we use intern video. And we also use the transcript to get the textual information. For visuals, we use SAM to segment the visual information. And once we have this video metadata, we run online algorithm to parse these temporal locations using GPT-4, spatial locations with using clip and GPT-4, and edit operations. So we ran pilot study with 3 novice editors and to evaluate the potential of ExpressEdit and get feedback on the design. And the task was to edit this given footage into an informative and engaging video. You can check out the details of the results from our main paper. And a few discussion points I want to discuss is that although the interface design was effective, they had to constantly scroll through multiple panels. So how might we facilitate navigation between various suggested edits? And how might we leverage the advantages of sketching beyond what is supported on ExpressEdit? And moving forward, how might we support iteration on the multimodal edits? So that's the end of my presentation, and please visit our demo and full paper presentation on Wednesday as well. Thank you.
Thank you. So any questions?
You might know about the new Sora, right? Like you give prompt and generate video. So what do you think about like auto-generating videos based on prompt versus just making minor edits? Like, have you compared that too at some point?
Yes, that's a very interesting and timely question. So currently video generating models, they are more focusing on generating visual content, like making a generated dog barking or something like that. But here we want to focus on informational videos, which is videos that convey some procedure or conceptual knowledge. And in that, we think that more investigation into this video generation is needed because it not only contains this like visual aspects of the video, but also contains verbal explanations. And that's where I think large language models can come in to collaborate with this current video generation models to make a coherent informational videos.
Thanks for great work and great talk. I'm curious about, so natural languages is intrinsically ambiguous, right? Like a lot of time the same thing can refer to multiple things.
Yeah.
So I'm curious about, like, in your project, did you explicitly deal with the ambiguation within natural language?
Yeah, so that's why we had this third design goal, which was about we should support this iteration on the edits and support the manual edits, manual like revision on the suggested edits. Because like many of the existing papers which dealt with this natural language modality, they pointed out this ambiguity as a like kind of problem. And so they all like unanimously say that we should support this. Users should be able to revise on the suggested AI produced output. So yeah, that's why we provided explanations on where on why this edit was suggested from the user comment, and also yeah, users could manually edit